So very good morning children. Today we are going to learn class 12th physics chapter 2 conceptual problems. This is module number 8. In module number 7 we finished with chapter 2. So we learned all the derivations of chapter 2 and also I gave you homework to do few numericals. So here I am going to discuss few previous year's questions, few conceptual problems of chapter 2. So this is question number 1. Four charges q minus q plus q and minus q are to be arranged respectively at four corners of side ABCD of square ABCD of side A. Find the work required to put together this arrangement. A charge q naught is brought to the center of the square, the four charges being held fixed. How much extra work is needed to do this? So four charges are there and we have to arrange this at the four corners of a square ABCD. So we have a square ABCD and at the four corners we have plus q and then minus q charge and then plus q charge and then minus q charge, and the length of the side is actually A. So square being a square, all the sides are equal. Find the work required to put together this arrangement. So the work, we know that work is equal to what? Energy. And total energy of the system is very simple. The formula for energy is K into first charge into the second charge divided by the distance. K Q1 Q2 upon R. That's a formula we have. Potential energy. So here are how many potential energies? Four potential energies at the sides. So K, let's start from AB. So it will be K Q1 Q2. So plus into minus minus upon A, and here also minus K Q cube means Q square upon A, and here also minus K Q square upon A, and then dA minus K Q square upon A. So in short I should say there are four K Q square upon A. Because this is plus into minus minus, plus into plus minus, plus into minus minus, minus into plus minus. So every side we have minus 4 kq square upon A. And then we have two diagonals. And according to Pythagoras theorem, this is A and this is A, then this will be under root A square plus A square will be equal to under root 2A. So here is a potential energy between two positive charges, so it will be plus kq square upon under root 2a, and here also plus kq square upon under root 2a, because minus into minus plus. So the final answer what you are getting is, if you are taking kq square upon a common, you will get 1 upon root 2 plus 1 upon root 2, 2 upon root 2 minus 4. So 2 upon root 2 is actually 2 can be written like root 2 into root 2. So you'll get kq square upon a root 2 minus 4. Definitely it is a negative quantity, so we have a negative potential energy. So this is the work required to put together this arrangement. And the next is, the charge q naught is brought to the center of the square, the four charges being held fixed. How much extra work is needed to do this? कितना extra work चाहिए अगर आप इसकी center पे, so now this is root 2a, this is also root 2a, so at the center of the square you're going to bring a charge Q naught, then how much extra work is to be done? So the second part is we are going to bring a charge Q naught. So we have another formula. Work done is equal to potential energy, but the potential energy is equal to charge into potential at that point. So what is the potential at that point? At the center. There's a potential due to this charge. So this is root 2a, this will be root 2a divided by 2. So it will be a upon root 2, this distance. So potential is kq upon a upon root 2. So this will be root 2. And due to this it will be minus kqa upon root 2 will be in the numerator. This will be plus kq upon root 2 will be in the numerator. And this will be minus kq a upon root 2 will be in the numerator. So the final answer is q naught into 0, because potential at the center is 0 here. So the extra work done to bring q naught is 0. So there is no need to do any work to bring a charge to the center of this square ABCD here. So this is question number 2. An electric dipole of length 4 cm when placed with its axis making an angle 60 degree with a uniform electric field experience a torque 4 root 3 Newton meter. Calculate the potential energy of the dipole if it has a charge 8 nanocoulomb plus or minus 8 nanocoulomb, because an electric dipole has a positive charge and a negative charge separated by a finite distance. An electric dipole of length 4 centimeter. So the length is 4 centimeter here. And when placed to the axis making an angle 60 degree, the uniform electric field experience a torque. So the formula for torque is PE sine theta. So an electric dipole making an angle 60 degree with the uniform electric field. So 4 root 3 is the torque. P we don't know, E we don't know. Even we can find P by the formula charge into length. But it is not required right now. They are not asking find the dipole moment and all. Sine theta, sine 60 degree, because it makes an angle 60 degree with a uniform electric field. So what is the value of P here? Sine 60 is root 3 by 2, 4 root 3. So root 3 cancels, 2 will go there. So PE is equal to 8, whatever its unit is. But now we have to calculate the potential energy. What is the formula for potential energy? PE cos theta. That is the potential energy. In more clear, it is minus P cos theta. P dot E. This is P cross E. So minus, what is P? P we don't know. We did not find P and E separately, but P E altogether is 8 cos 60. And we know what is the value of cos 60, 1 by 2. So the answer is minus 4. And potential energy is measured in joules. So minus 4 joules is the potential energy of the dipole. And we did not use this value 8 nanocoulomb. We did not use this value 4 centimeter, because the same P is getting repeated here. So you don't need to put the values and all and make the calculation very long. So it is maybe a 2 marks question and you are doing pages after page is meaningless. So this is an easy way to do it. Now the next question. This is question number 3. Find the charge on the capacitor as shown in the circuit. So there is a capacitor shown 6 microfarad. and then two resistors 10 ohm 20 ohm, and then connected to a cell of 2 volt. So this you have already learned this type of connections in class 10. So you can use Ohm's law here. V is equal to IR. So anyway, this half of the part is part of the next chapter, but this you have already learned in class 10, so you can easily understand. So by using Ohm's law, you can find the current here, and the important thing over here is when you connect a capacitor gets charged. So the potential across this resistor and the capacitor is the same because they are parallelly connected. So in parallel connection, potential is the same, and so we will use the potential to be the same, and there is no current through the capacitor because capacitor, once it gets charged, it is actually a disconnected device. In between these two parallel plates there is no connection, so the charges cannot flow. Once the capacitor is charged, a DC current, a direct current cannot flow through this. So we can now remove this capacitor and just consider this as a single circuit. Then what is the current through the circuit? The current through the circuit is I is equal to V upon R. So V is 2 volt and R is 10 plus 20 because series connection. The resistors are being added, but the capacitors are not being added. It just have the opposite formula. But here it is resistor, so 2 upon 30 ampere is so ampere is a unit of current. We'll be again learning it in the next chapter 3. But this you have already learned in class 10 also. So this is a very simple formula to find the current through the circuit because there is no current through the capacitor. And now what is the voltage across the 10 ohm resistor? Voltage across the 10 ohm resistor is V is equal to I into R, and I is 2 upon 30 and resistance is 10, so it is 2 upon 3 volt, whatever the value in points in decimal point, but we are not going to find anyway in decimal point because we have to find the charge in the capacitor, not the potential. But so without finding potential you cannot find the charge because the formula is C is equal to Q upon V, or Q is equal to C into V. So in order to find charge you need to know the capacitance of the capacitor and the potential across the plates of the capacitor. So capacitance is already given 6 microfarad, but the potential we found by this method, by Ohm's law, 2 upon 3 volt. So then charge on the capacitor is equal to capacitance 6 microfarad means 6 into 10 to the power minus 6 multiplied by voltage. Voltage is 2 upon 3. So you get the answer 4 microcoulomb. It is 4 microcoulomb, plus 4 microcoulomb on one of the plates and minus 4 microcoulomb on the other plate. 2 to the 4 or 10 to the power minus 6 is micro, and the unit is coulomb for charge. So the next question, this is question number 4. A slab of material of dielectric constant K has the same area as that of plates of a parallel plate capacitor, but has thickness D by 3, where D is the separation between the plates of the capacitor. So D is the separation between the plates of the capacitor, and a slab is there. Find out the expression for its capacitance when the slab is inserted between the plates of the capacitor. So if the slab is inserted and the slab has a thickness, how much? D by 3. And we have a formula for finding the potential. Capacitance has a formula charge upon potential. And here potential is electric field into distance. But there are two electric field. One is a modified electric field plus an original electric field. d minus d by 3, because this is d minus d by 3. So 2d by 3. So E dash will be E upon K, because when you insert a dielectric, we have already the derivation that K times the electric field decreases, plus E into 2d by 3, 3d minus d. So you will get, so this is the potential at this point, and this one is the potential at this, difference between this, which is not modified field and which is for modified field. So it will be like E1 upon 3, also you can take it outside, so you get 1 upon K plus 2. Upon 1. So you get an answer like here. Instead of E we can write electric field is sigma upon epsilon naught, or D upon 3 is already there, so it will be like 1 plus 2K upon K, taking LCM. And instead of the sigma we can write Q upon A, because sigma is charge density, charge upon area. So 2K plus 1 upon K. And we already know the formula C is equal to Q divided by V. So C is equal to Q divided by this everything. So you can multiply it. So the numerator things will go upside like this. Divided by means the denominator will go into the numerator and numerator will come into the denominator. So QD 2K plus 1. So QQ cancel. So you get a formula A epsilon naught upon D into 3K upon 2K plus 1, which is the capacitance. And if A epsilon naught upon D is the original capacitance, then we can say that C is equal to C naught, which is the original capacitance, into 3K upon 2K plus 1. Here where the area A represents the area of the plates, which is not given here, so you have to assume that the area of the plates is A. So next question. So this is question number 5. Two parallel plate capacitor X and Y have the same area of plates and same separation between them. X has air between the plates while Y contains dielectric medium of epsilon r is equal to 4. Means the value of K is equal to 4. That is indirectly epsilon r. Relative electrical permittivity, yeah, dielectric constant. Calculate the capacitance of each capacitor if equivalent capacitance of the combination is 4 microfarad. And calculate the potential difference between the plates of X and the plates of Y. And what is the ratio of the electrostatic energy stored in X and Y? So first of all, we know for a formula for a capacitor is A epsilon naught upon D. So when you say two parallel plate capacitor have the same area is same, and same separation means distance is same, this means that the capacitance is same. But this Y has a medium and X has only air between the plates. So for X it is a formula, but for Y the formula is Ka epsilon naught upon D. So Cx, or I should say Cy is equal to K into Cx. So here Cy is equal to, what is K? 4 into Cx. So then we already know this is series combination. So 1 upon Cy plus 1 upon Cx is equal to the total 1, that is 1 upon 4 microfarad. So this is in microfarad, this is in microfarad, and here I am writing only 4 because it's understood that everything is in microfarad. It's a common uh, unit for all these things here right now. So then you can calculate this question like this. Cy is equal to 4cx, so 1 upon 4cx plus 1 upon cx is equal to 1 upon 4. So you take the LCM, 4cx, or you can take the cx to be common here, even 1 upon cx to be common, and you'll get 1 upon 4 plus 1 upon 1 is equal to 1 upon 4. And then 1 upon cx is equal to 4 ones are 4, 1 ones are 1, so 1 plus 4, 5. 5 upon 4 is equal to 1 upon 4, 4 cancel. So the cx will go there, cross multiplication, 5 is equal to cx. So it means that cx is not actually 5, it is 5 microfarad actually. So because it is microfarad here, and every unit is microfarad, so finally the unit you have to write 5 microfarad, because here we did only with the numerical value, not the unit. So what about then Cy? Therefore Cy is equal to 4 into Cx is equal to 20 microfarad. So calculate the capacitance of each capacitor. So we have done it. For X it is 5 and for Y it is 4 times, means 20 microfarad. And the next question is calculate the potential difference between the plates X and Y. Between the plates of X and between the plates of Y. Means what is the potential difference appearing here? What is the potential difference appearing here? So for that we have a major formula like C is equal to Q upon V. So V is equal to Q upon C. So you see here, what is a charge? If you know the charge, if you know the capacitance, and you can easily find the potential. So you already know the capacitance, but you don't know the charge. But in series combination, we know the charge is same. For a series combination, charge is same. For a parallel combination, potential difference is same. So at a series combination, so we are going to find the charge somehow. So in order to find the charge, Q is equal to, so the overall charge, overall capacitance. What is the overall capacitance is already given in the question, 4 microfarad. So C is equal to, Q is equal to C into V, where C is the overall capacitance 4 microfarad, 10 to the power minus 6, or voltage is equal to 12 volt. So 48 into 10 to the power minus 6 coulomb is the charge, the total charge on this. But the question is, you have to find what is the potential difference. So potential difference is, if you want to find the potential difference in charge upon its own capacitance, overall capacitance, then overall potential difference, then its own capacitance and its own potential difference. So Vx is equal to Q upon Cx, or Vy is equal to Q upon Cy. Q is common here. Vx is equal to Q is 48 into 10 to the power minus 6 divided by Cx. Cx is 5 into 10 to the power minus 6. So 48 upon 5. 9, 5, so 45, 3, so 9.6 volt. Here it is Vy is equal to Q upon C4. So 48 upon 20. So it will be like 2.4 volt. So the total voltage is anyway 12 volt only, because in series combination the potential difference is actually splits, and the total potential V must be equal to what? V1 plus V2. You have Vx plus Vy. So 9.6 plus 2.4 will be 12. So that is again accurate. So there are more methods to do it. There are shortcut methods even to do it, but this is a proper way to do. What is the ratio of electrostatic energy stored in X and Y? That's the third question. ratio of electrostatic energy stored in X and Y. So if you want to find the ratio of electrostatic energy stored, so what is the formula for electrostatic energy? So this is the second part I have done, and this is the first part, and now we are going to do the third part. Ratio of electrostatic energy stored in X and Y. So Ux upon Uy I have to find. But what is U? Is half CV square. So we know what is a C and we know what is V. So half Cx Vx square, half Cy Vy square. Half cancel. And Cx is 5 into 10 to the minus 6 and Cy is 20 into 10 to the minus 6. 4 times, or Vx is 9.6, yeah, 48 upon 5 into 48 upon 5 divided by, and this one is 24 upon 10 into 24 upon 10. So for the easy calculation I am doing it like this. Even I can go for the exact values, 9.6 into 9.6 divided by 2.4 into 2.4. So it will become like Ux upon Uy is equal to 1 upon 4 is already there, 48 upon 5 into 48 upon 5, and 24 upon 10 will become 10 upon 24 into 10 upon 24. So 2 times, 2 times, 2 times and 2 times, so 2 is a 4. So you get 4 ratio 1. Even you can use another formula like Ux upon Uy is equal to half Q square upon Cx divided by half Q square upon Cy. So Q square same, half or half same, because in series connection Q square, Q is same, charge is same. So it is equal to 1 upon Cx divided by 1 upon Cy, so it will be Cy by Cx, and Cy is already 4 Cx. So again you will get 4 ratio 1. So this is how we can do even without putting the values. So students, here I have shown you how to solve conceptual problems. These are very few only. There are hundreds of questions on this chapter, and this chapter is really a heavy chapter. So you just rewatch or watch again and again all those videos that has been sent to you, and try to solve. You'll get a lot of online contents, but don't depend on the answers. You just try to solve the questions. You can get a lot of previous year's questions, even the CBSE websites, and then download those question papers and try to solve in the questions which is of chapter 1 and chapter 2. So this time we have finished these 2 chapters, and this is actually your periodical 1 syllabus, and chapter 3 will be starting later, and which has more practical content. So unless you learn it practically, it will be very difficult to learn chapter 3. Even you have almost 7 practicals on electricity. So this time the syllabus has according to CBSE circular which was issued right in the first week of April, or last week of in the last week of March, I should say, in last week of March. So you have a lot of changes in the practicals, but we are looking forward for further updates on the syllabus as the COVID-19 crisis is going on. So you revise all these 2 chapters, and these 2 chapters are actually electrostatics, charges at rest. A lot of numerical and conceptual questions are there, and this is one unit for your examination.